Today, when you leave your PC with common Windows default settings, it will stay unlocked for 5 minutes, and anybody can access your sensitive data without your password. On top of which, if the screen is left on for 5 minutes, it continues to draw power. Login procedures can be quite slow and painful, and waiting for your PC to wake up for a long time can be quite frustrating. Sometimes people even like to peek over your shoulder to see what is happening on your screen. This can present big problems for personal privacy. And sometimes it can be quite distracting when we're pressing keys during presentations when we want to switch slides. At STMicroelectronics, we've considered how the accumulation of all these seemingly minor points can be quite frustrating for users, and we've come up with an interesting and practical solution. The time-of-flight sensor plus a suite of algorithms are monitoring the presence of the user in front of their PC and the surroundings. The time-of-flight sensor itself is hidden in the top bezel of the laptop screen. The ST Presence turnkey solution enables a variety of use cases. Walk-away lock and screen switch off, which improves the security of your PC by detecting a lack of presence and switching the PC off so other people can't access it, and in so doing also extending its battery lifetime. Zero touch login. Here, the time-of-flight sensor detects the user coming back to their desk and automatically starts the Hello Login authentication with no key press or delay of any kind. Intruder alert. Here, the system detects a human presence that is behind you and could be watching your screen over your shoulder, and then it raises a warning. Gesture recognition. This can be used to control your applications without having to touch either the keyboard, the screen, or the mouse. For your information, the ST Presence solution is qualified at Intel and Microsoft for catalog sensors and modern standby. So, what is the time-of-flight technical principle, and how does it enable the presence use case? Here we can see that the benefits are that the flight sense sensor does an actual distance measurement, and it is independent of the target color, shape, or reflectance. It uses invisible infrared light, and it is highly accurate and has very low power consumption. It is also contained in an all-in-one package with the emitter and receiver included, and it is easy to integrate and hide behind a cover glass on a PC or a laptop. The time of flight itself does not generate any image and ensures users' privacy, unlike a camera. The distance between the user and the PC is permanently measured at high accuracy, allowing for the detection of micro movements like a human breathing, which in turn enables the differentiation between an immobile user and an object. This is a major benefit. For example, when the user is leaving their desk but their chair remains in the field of view, the presence algorithms will detect that it is a chair and will switch off the screen and lock the PC. Such algorithms also enable the PC screen to stay on when an immobile user is watching a video, while the screen would be switched off if an object is left in front of the PC. The latest VL53L5 time-of-flight sensor includes 8x8 zones, which enables scene analysis and tracks the movements of the user without capturing an image, unlike a camera which captures images and can then present privacy problems. In the demo, we are showing you the camera, and then we are removing it to show you exactly how we protect people's privacy. The sensor can, for example, detect multiple users in the field of view in order to keep the PC alive, even if one of the users is leaving the field of view, for example. The user can also dynamically program the sensor's field of view in order to exclude some zones on the side of the field of view or in the background to avoid that some people passing by might wake up the system. It is also possible to detect that someone is approaching behind the user and to generate an intruder alert. The sensor also integrates an autonomous ranging mode. When the user has left, the sensor will report that there is no presence, and the host will switch to modern standby, while the sensor becomes autonomous in low power mode. The sensor will also wake up the system automatically when the user comes back to their desk and will instantaneously start the Windows Hello Login authentication without waiting for the user to press the keyboard. So, a quick word about gesture recognition. The X, Y, and Z coordinates of the target are reported to the host, and some algorithms allow you to recognize some gestures like directional swipes, taps, and movement control. The 8x8 raw data is transferred to the CPU, and the user can develop their own applications, like AI, for example, in order to analyze the behavior of the user. For more information about the ST Presence solution and the associated hardware evaluation tools and software resources, please check out st.com/TOF. Also, we invite you to contact your local ST sales representative.